Alright everybody, so today I want to talk to you about the Cori and the Cahill cycles, and these particular cycles I think are a source of a lot of confusion for a lot of students, particularly because I don't think that they're presented particularly well, and the diagram that you see in first aid actually, I think is actually pretty confusing, but if you think about it simply and think about it in the way that I'm about to present it, it'll make it a lot more memorable. So with that in mind, the first thing that I want to do here is I just want to, I'm going to draw out the Cori and the Cahill cycle in a way that I hope will be a little bit more rememberable for you. So the first thing that I want you to do is I want you to just take a sheet of paper and right in the middle of it, just write pyruvate. So you've written pyruvate. Now what I want you to do is I want you to draw 3 arrows emanating from pyruvate. I'll draw them like this, and like this, and like this. And now we're going to work clockwise. And starting from the left, I want you to write alanine. And on the top, I want you to write glucose. And on the bottom right here, I want you to write lactate. So what I've drawn for you is what I consider the Cori-Cahill triangle. And you'll notice that if you move from bottom left up and then to bottom right, it's all in alphabetical order. So A, G, L, AGL, alanine, glucose, lactate. To simplify this even more, I want you to write Cahill up top left, and then Cori up top right. And you'll notice that these are also in alphabetical order from left to right. CA to CO. And the way that I have this organized, you'll notice if you correlate it with the first aid book, is that if you incorporate alanine, pyruvate, and glucose into this pathway, you will be looking at the Cahill cycle. And if you incorporate glucose, pyruvate, and lactate, you'll be talking about the Cori cycle. So this is the way that I like to have this concept organized initially. So moving on, the next important lesson that I want you to know is that every time you move towards glucose in this pathway, you are working in the liver. So if I work from alanine to pyruvate to glucose, I am in the liver. If I am working from lactate, pyruvate to glucose, I am in the liver. Easy enough. And it kind of makes sense too, because as you move from pyruvate to glucose, that's gluconeogenesis. And gluconeogenesis primarily takes place in the liver. It also works in the kidney to some respects, but for the most part, just think gluconeogenesis, it works in the liver. And for the purpose of the Cori and Cahill cycle anyway, we're working in the muscle and the liver, so it only makes sense to think about these cycles really working in the liver anyway, and thinking about gluconeogenesis as a pathway that works in the liver. So just to reiterate, the Cahill cycle, remember, it is a pathway that primarily deals with glucose, pyruvate, and alanine, and the Cori cycle is a pathway that primarily works with glucose, pyruvate, and lactate. And all of the metabolites in this pathway, or the products of these pathways, like glucose, alanine, and lactate, they're all going to cross over from the muscle to the liver or liver to muscle in their respective pathway. So for example, if you look at your diagram in first aid, you'll notice that alanine crosses over to the liver, where it can then be processed by the liver in various forms. And remember, as we work from alanine to glucose, think of it like gluconeogenesis. So it only makes sense that alanine would be transported, say, from the muscle to the liver, where it can undergo gluconeogenesis. Similarly, think of lactate. Say you're burning a lot of fuel, your muscles are building up a lot of lactic acid, so it only makes sense that, say, if your muscles are burning up a lot of energy and they need to convert to a different energy source, say lactic acid, that lactate would be converted from muscle to liver anyway and then be processed in the liver. So that being said, once glucose is made in the liver from gluconeogenesis, it can then go back to various tissues where it can then go through glycolysis and be used for energy production. So remember, the purpose of these pathways is to process ammonia, and alanine is a critical component to this particular pathway. I want to focus on alanine and pyruvate particularly. As we move from pyruvate to alanine, we are essentially transporting ammonia into the liver so it can be processed in the urea cycle, which also takes place in the liver. So what I'm going to do is I'm going to draw this arrow, and it's going to be a double arrow actually, because we're moving in both directions depending on where we are, whether it's the liver or the muscle. And as we move from pyruvate to alanine, we generate alpha-ketoglutarate. From glutamate. And then glutamate is going to be an integral amino acid that's going to help us when we transport ammonia. And you'll notice another little memory device here is that these are also in alphabetical order from left to right, so alpha or A and G for glutamate, if that helps you. So depending on which direction that we're working in, say if we're working in the muscle, we're going to be moving from pyruvate to alanine, and then remember alanine is going to get transported to the liver where it can then be processed back into glucose. So if we start from alanine, say in the liver, well, we have to go in the opposite direction, so we're going to take alpha-ketoglutarate and then convert it back into glutamate. And then eventually this will become pyruvate and glucose. But the important step here is that the alpha-ketoglutarate becomes glutamate. And this process is also not without other metabolites that you'll need to know. And particularly, this is just a one-way arrow that I'm going to draw. And this is going to be any amino acid that you have, basically. And that amino acid is going to be converted into an alpha-keto acid. So the way that you can think about this too is that as you move from, say, left to right from the alpha-keto acid or alpha-ketoglutarate to glutamate, you are going to make from an alpha-ketoglutarate an alpha-keto acid. And your amino acids now are going to be your primary source of ammonia. So NH3, and that is then converted into a glutamate, which is also NH3. And then as you move again from pyruvate to alanine, your alanine is also going to be a source of ammonia. So then remember, as we move from the muscle to the liver, we are transporting these amino acids or this ammonia now into various products and metabolites where it eventually gets to alanine. And now all of a sudden we're in the liver. So then what happens to this ammonia? Well, the ammonia, it goes back into glutamate. And through various processes, we'll be able to eliminate it in the form of urea via the urea cycle. So, as an aside, I am just going to say that this glutamate here is going to be, or a component before the urea cycle. So I'll draw it like this. So I'll leave it there. Hopefully this way will help you organize your thoughts about the Cahill and Cori cycle, and hopefully simplify this process a little bit.